Hello, Mr. Bainey here. This lesson is 2.2, Creating and Solving Equations. Our essential skill for this lesson is how do you use an equation to model and solve a real-world problem. And the standard ACED.1, create and solve equations and inequalities. We're only going to focus on the equations part, of course. And we're going to skip ahead a little bit. Go on to the next page. The first type of example we're going to look at is setting up an equation that might have some distributive property use involved. And not to say that you have to set it up that way, but it is a way to set it up. So let's look at the example that's all the way at the bottom here. We're going to do some fill in the blank on this one. At the bottom, part B, Mari, Carlos, and Amanda collect stamps. Carlos has 5 more stamps than Mari. Okay. Amanda has 3 times as many stamps as Carlos. Altogether, they have 100 stamps. Find the number of stamps each person has. So, the first step here is to understand the situation. Okay, make sense of it. If it helps, don't even think about the numbers. Just try to understand what's going on. We have 3 people involved, Mari, Carlos, and Amanda, and they collect stamps. So they have a number of stamps. That's going to be our number there, our math. Altogether, they have 100 stamps. So Mari has some stamps, Carlos has some stamps, and Amanda also has some stamps. And so our task is to find how many each one has. Now, they have compared each other's amount of stamps. So since we start off with saying Carlos and how it compares to Mari, we're going to set Mari as the variable, as our unknown. So we're going to use S. Carlos has 5 more than Mari, which means Carlos is going to have 5 plus S, or S plus 5, doesn't really matter. So now that we have an expression for Mari, which is S, we have an expression for Carlos, which is 5 plus S. Then the last part that I underlined, Amanda has 3 times as many stamps as Carlos. So we know Carlos is 5 plus S. So Amanda has 3 times as much as this. So Amanda is going to have 3 times that, right? And that by that, I mean 5 plus S, or S plus 5. I think you'll see that on the next page. So let's go on to the next page, page 57, to finish this up. Let's fill in the blank here. I'm on the second line. Let S represent the number of stamps Mari has. We've already done that. Carlos is going to have S plus 5 stamps, and Amanda has 3 times that. So what do I know about the amount of stamps that 3 of them all have together? They have 100. So I'm going to add S is Mari, S plus 5 is Carlos, right? And then 3 times S plus 5 is Amanda. So those are the 3 people. You see plus signs in between each of those, and when I add them together, it should equal 100. So this is my equation. Definitely the most difficult part of this whole problem is setting this up. Let's go through and solve it very quickly here. So I'm going to rewrite it. Use distributive property, and you should get S plus 5 plus 3S plus 15. I got that from doing the 3 times the 5 in my distributive property. That still equals 100. And by the way, the right side over here is our justification. If you remember back from lesson 1.1, this tells us why we're making these steps over here that are on the left side. So next step, let's combine like terms. I got S plus 3S is a total of 5S. And then 5 plus 15 gives me 20. Subtract 20 on both sides, and 5s equals 80. Then divide 5 on both sides, and s equals 16. So s equals 16. You have to remember what s represents, what it means. It means the number of stamps that Mari has, which is 16. Carlos is going to have 5 more than that, right? So do 16 plus 5 to get that. And Amanda has 3 times what Carlos has. So 63. And just to make sure we have this right, we can definitely check our answer. This one's a little bit easier to check. Mari has 16. Carlos has 21. Amanda has 63. Yeah, those are the ones I came up with. I'm going to put a question mark here. Does that actually equal 100 as the problem originally said? And it does. If you don't believe me, put it into a calculator. It should come out to 100 on the left side. And so it does work. Okay, on the next page, I want you to give it a try. Number 5, your turn. Go ahead and pause it if you'd like to try it out for yourself, and then take a look at the solution after that. Okay, we're going to write and solve an equation to solve this problem. A rectangular garden is fenced on all sides with 256 feet of fencing. The garden is 8 feet longer than it is wide. Find the length and the width of the garden. So the fencing is the part that's going around. Right here, I'm trying to show it to you by just kind of tracing along the sides. That's the fence is going around, and there's 256 feet of it. So that's actually my perimeter. So the perimeter is 256 feet. Well, that's the first part, is you have to understand that. And then next, you got to figure out how we're going to put this into an equation to actually solve my task, which is finding the length and the width. The length is W plus 8 up at the top here, and the width is just W. So I know, here's just one way to set it up. There are so many ways to do this. But if I take the length, and then I have 2 of those, right? On my picture, the length is the top and the bottom of that rectangle. So I have 2 of those. And I'm also going to add the widths, and there's 2 of those. When I add up the 2 lengths and the 2 widths all together, that's going to give me my total perimeter, 256. And after that is just working it out, solving it. So I'm going to go through this quickly. Combine like terms now. 4W. I'm also going to subtract 16 on both sides. Hopefully I'm not doing too many steps here at once. And dividing 4 on both sides, division property of equality, gives me W equals 60. W, remember, is the width. So if my width is 60 feet, and the problem in words and in the picture tells me that the length is 8 feet longer than the width, so that tells me that the length is going to be 68 feet. And there's my solution. Okay, our next type of example is to try to create an equation where the variables are going to be on both sides of the equal sign. Okay, so let's take a look. Let's actually go to the your turns on this page. Do number 7 and 8. Claire bought just enough fencing to enclose a rectangular garden or a triangular garden. As shown, the 2 gardens have the same perimeter. How many feet of fencing did she buy? So what I'm going to do is I'm going to take the perimeter of the rectangle. Okay, that little notation is just to say the perimeter of the rectangle, and the perimeter of the triangle. And in the problem, it says the 2 gardens have the same perimeter. So that means they are equal to each other. Okay, so all I have to know is, how do I calculate perimeter? I know that it don't give me nice numbers here. They give me like some variable expressions. So I got, it's going to look a little messy, but here we go. The perimeter of the rectangle is 2 times this 3x minus 3. Okay, that's this part. 3x minus 3 is the length. So I got 2 of them, the top and the bottom. Okay, that's that part. Then I add the 2 widths. The width is x minus 3. So I got 2 of those. And that's my rectangle. Now a triangle, there's no formula for perimeter. You just take, there's 3 sides. You add up the length of all 3 sides. So it's 2x plus 1 plus 2x, 2x minus 1 plus 2x minus 1 plus 2x. Now I notice I have 2 of these. I got a 2x minus 1 here and a 2x minus 1 here. So if I just want to save some space, I write it as 2 times the 2x minus 1. And then don't forget the 2x after that. Okay, so certainly looks messy, but work one set of parentheses at a time using distributive property. I get 6x minus 6 plus 2x minus 6 equals 4x minus 2 plus 2x. And then combining like terms gives me 8x minus 12 equals 6x minus 2. And then I'm going to do 2 steps here at once just because I'm running out of room here. But subtracting 6x on both sides will give me 2x. And then adding 12 to both sides will give me 10 on the other side. Okay, this will lead me to x equals 5. And I'm not done, right? It asked me how many feet of fencing did she buy. Now that I know what x is, this is going into x up here, and also here, and also here. Or I could do the rectangle also, but that has more sides. You know, I want to try to save myself a little time here. So let's do this mentally. If x is 5, 2 times 5 is 10, minus 1 is 9. So this side is 9, which makes this side 9. And then if I substitute 5 in here, I'm going to get 10. So 9 plus 9 plus 10 is 28. So 28 feet is my solution. Okay, there you have it. Number 8, please give it a try. Pause it. Unpause it when you're ready to see the solution. I'm going to erase some of this here so I have some space to work. Actually, I'm going to erase all of it. Let's go ahead and work out number 8. A veterinarian is changing the diets of 2 animals, Simba and Cuddles. Simba currently consumes 1,200 calories per day. That number will increase by 100 calories each day. Cuddles currently consumes 3,230 calories a day. That number will decrease by 190 calories each day. The patterns will continue until both animals are consuming the same number of calories each day. In how many days will that be? How many calories will each animal be consuming each day then? Okay, very, very long problem. You're probably going to have to reread it and reread it and reread it just to make sense of it, okay, before you do any math at all. That's okay to do. Very common. So, let's look at one at a time. So I know that I have Simba and I have Cuddles. And we're looking at their diets. We want their diets to be the same, or we want the number of calories they're consuming to be the same. So Simba is 1,200 calories per day. So in a day, 1,200 calories. No, that's currently, sorry. That number is going to increase by 100 calories each day. So the keyword there, increase, means that we're going to add 100 for every day. I'm going to use D as the number of days. Okay, so that means after the first day, it's going to be what, 1,300 calories? After the second day, 1,400. After the third day, 1,500, and so on. Cuddles currently consumes 3,230, way more calories than Simba, but that's decreasing each day. So now we're subtracting. Okay, I'm going to underline that word decrease. Subtracting 190 calories for every day after that. So once this trend continues, Simba's consuming more and more and more and more calories. In addition to that 1,200 he started with, Cuddles is going to consume less and less and less and less calories each day, starting from the 3,230. So eventually, they're going to meet and they're going to be equal. We want to figure out what that D, that number of days, is going to be. Okay? So with that, again, the setting up the equation is the hardest part. So I'm not going to actually finish this problem. I'll leave that up to you. I'm going to go ahead and stop here. That's it for the lesson. Thank you for watching. Goodbye.